Again, hi everyone, welcome to the SAM Student Talk number 20. We have a full roster of amazing products to share with you. My name is Oasis Jen. I am the Chief of Staff here at Polygence, and I'm also a recent graduate at Yale University. Today, we have 5 student presenters presenting on a variety of topics. In the room today with us is Alex Winnett, a PhD student at the California Institute of Technology. She has taught and mentored students in a variety courses and capacities over the years. Alex will be scoring each student presentation along with myself. Please type your questions in the chat if you have any for each speaker. We will allow 2 minutes for questions after each presentation. For order today, we'll have Nathan first, and then Ryan, Arnav, Sonia, and Mahati. And let me know if I'm pronouncing your name wrong. I'd love to get it right once it's your turn. Again, thank you so much. And without further ado, I'll turn the stage to Nathan.
Hello, can you hear me?
Yep. Yeah, the screen share button is the 4th one.
Can everybody see it?
Perfect.
Okay. Hi, everyone. My name is Nathan Su, and I'm here to talk to you today about a research paper that I wrote during my time at Polygence titled Single Multiplayer Video Gamers Looking at Their Experiences, Behavior, and Psychosocial Well-Being During the COVID-19 Pandemic, and I wrote this with my mentor, Andy. So, a little bit of background about myself. I'm Nathan Su. I'm a junior at Bellarmine College Preparatory in San Jose, California, and my interests include playing video games, doing art, and playing volleyball. So some of my experience during the pandemic with video games is I played to relax or to reconnect with old friends. But while I was playing, I observed that some of my friends seemed to be more aggressive online, especially when we were interacting with strangers. And so that's kind of what inspired me for this project. Some quick definitions of about video games. There are single-player video games, games played by one person, and then there are multiplayer video games, which include MMOs, which stands for multiplayer or massively multiplayer online video games, where you interact with other players in the same game in order to play. And so while I was researching, I came across several perspectives of video games via articles. And so there was both a negative and a positive aspect to video games from these articles. For negative, there was an increase in aggression after playing violent video games in boys. MOBAs, which is multiplayer online battle arenas, were associated with lower psychosocial well-being and low self-esteem. And then people with high anxiety also had a higher rate of problematic internet use. For the positive aspect, video games seem to provide some veterans with a form of personal medicine that aided in recovery from trauma. There was a genre of games known as AR, which is augmented reality, that has potential to promote physical and mental health during the pandemic. And then there was a qualitative study focused on open-ended questions to explore the benefits of video games during the COVID-19 pandemic. For me, the aim of the project was to compare single player and multiplayer video games. So for single player, I looked at time playing and sleep schedule, motivations, aggression, and mental health. And then for multiplayer, I looked at very similar things, but I also looked at social interaction. So here are my methods. There were 2 online surveys that I used, one for single player and one for multiplayer, and they were anonymous. I distributed them via online communities such as Reddit, Discord, Facebook, and other online gaming forums. I collected responses between June 28th and July 29th in 2021. And we were mostly studying the time period of the pandemic when most people were on lockdown / sheltering in place. And then for analysis, I used RStudio, and one of the statistical tests I ran was a 2-proportion Z-test. And statistical significance for this study was measured with a p-value of less than 0.05. Here are our demographics. We had 260 responses split between single player and multiplayer, 132 single player and 128 multiplayer. The average age of participants was 24. Single player had a standard deviation of plus or minus 8. Multiplayer had a standard deviation of plus or minus 11. 60 to 65% of our participants were male. 90% sheltered in place for an average of 11 months. 80% self-reported as introverts, and 40% said they had been diagnosed with depression or anxiety, either in the past or the present. And so the first big statistics we looked at was playtime. During the pandemic, participants reported that they played a lot more video games. So people who played 5 or more hours a day had a 98.3% increase in single player and a 128% increase in multiplayer. And then we also looked at days per week played. So people who played 5 or more days per week, there was a 65.9% increase in single player and a 252.5% increase in multiplayer. And then this graph right here is a representation of the increase in the amount of time played. And all of these changes were statistically significant. The next one is sleep schedule. Both types of players stayed up later playing video games, with 50% of MMO players and 36% of single player game players admitted that their sleep schedule got worse due to gaming. The percentage of people who went to bed later than 2 a.m. During the pandemic increased by 193.4% for single player and 114% for multiplayer. And then this graph is a representation of that increase. We also looked at the motivations for playing. So we asked them various motivations for why they played. And single players tended to choose decrease anxiety and to get away from real life as a motivation, whereas MMO players play to socialize, which can be seen in the graphs. On the left is the motivations for playing single player games. There was statistical increase from before the pandemic to during the pandemic for the motivation of decreasing anxiety and to get away from real life. And then for multiplayer, we added the same sort of the same ones as a single player on the multiplayer graph, but they didn't have as much of a statistical difference between before and during. The only one that did was the motivation to socialize, which was which you can see on the graph. And then the next behavior we looked at was aggressive behavior, and a majority of both players types did not perceive their actions as aggressive during playing, which can be seen on the two graphs. But however, 47% more MMO players showed aggressive behavior compared to single players. And then we did do a logistics regression test comparing amount of time played and aggression, but nothing statistical came out of it. So it seems that longer play time does not increase aggression. And then the last statistic we looked at was mental health, which can be defined as a person's condition with regards to their psychological and emotional well-being. Social well-being can affect mental health, and we asked some indicator questions, and we looked for over or under eating, irregular sleep schedule, pulling away from people or usual activities, low energy, feeling numb or like nothing matters, having unexplained aches and pains, feeling helplessness or hopelessness. And here are the results for those. Approximately 40 to 50% of both player types showed indicators of worsening mental health, except for the indicator having unexplained aches and pains. However, though, when asked directly, 45% of single player and 31% of MMO players reported improved mental well-being while playing video games. And then 92% of single and 67% of MMO players reported feeling relaxed while playing. And then this graph is a representation that compares single and multiplayer indicator questions. So the conclusions that I drew from this study were that gamers look to single player video games to help with relaxation, stress reduction, and perhaps an improvement in mental health, while people who played multiplayer games tended to play to increase social interaction and perhaps improve their social well-being. And as I said before, longer playing time did not seem to be associated with more perceived aggressive behavior. Here are my references. And then I just want to say thank you to my mentor, Andy. He was invaluable for this project. I wouldn't have been able to complete it without him. And I also want to thank the Polygence team for allowing me to pursue this topic and to prove to my parents that video games aren't so bad.
Thank you, Nathan. That was excellent. For the audience, please feel free to drop your question in the chat box, and I'll ask on your behalf. And while we wait, I actually do have a question for you. So, like, online games are really like the new social hubs for realities and communities online, especially during the pandemic. Do you have any like recommendations and suggestions for like new gamers so that we're not really turning aggressive, and we're actually like gaining a new community and a new group of supporters while playing games?
I would say, as a recommendation, look for a Discord community that sort of specializes in the game that you like to play. That way you can talk with people who share your interests, and there'll be a lot less like conflict between you if you instead of going to like an open forum. Look for like a bunch of people who also like the same thing that you do.
Cool. And we also have a question, Michael. Were you surprised by the results?
I was surprised by the results because before I started the study, I thought that the multiplayer participants would be a lot more aggressive and show a lot more of like exhibit more aggressive behaviors, because that's what I had observed playing with my friends. Because when we played, things could get heated and people would start being super aggressive. But it turns out, at least from our participants, that that wasn't the case. That they didn't really show aggressive behavior.
Got it. And also, Michael followed up saying that, can you explain how communities like Discord work during the pandemic to encourage social interactions?
So Discord is a platform where you can either talk with like in a voice chat or talk with people like through just a regular chat, and it allows people in different areas it allows people from all over the world to sort of come together and like interact with each other. And I think that was really important during the pandemic, where we couldn't go outside and we couldn't really interact with our friends, but you could still talk to them and through Discord and these communities.
Got it. Also, Kim asked, if you could take this study to a larger sample, are there things you would like to do differently?
I think I would like to design the survey a little bit more efficiently, because I had some questions that weren't super relevant to the site. But if I were to take this to a larger community, I think I would keep it mostly the same, because I thought we had some good results.
Got it. And last question from our judge, Alex. She says, nice talk, Nathan. Do you think the impact of video games can vary based on the age of the player? If so, how might they vary?
I think that they can vary. We didn't look into this very much. We didn't compare age with things because we didn't have time. But I think, at least from what I saw, that the younger you might be a little bit more emotional, but older players who have more experience and are more mature would tend to lash out less.
And we actually got a new question from Michael too. Do you think the survey has utility in addressing the results of this depression during the pandemic?
Um, for specific people, I don't think we could use a survey to address the results of depression during the pandemic, because it was completely anonymous. So we would have no way of like pinning it to a person. But I think in general, and also the questions we asked were like in the past if they had ever been diagnosed with depression or anxiety. So it doesn't necessarily mean that they had it during the pandemic. It's just they had it at one point, and then yeah. So
Got it. Thank you, Nathan. That was very detailed and very informational. Thank you so much.
thank you very much as well for the opportunity.
Thank you. All right, so next up, we have Ryan. Ryan is a sophomore from Irvine, California, and I am going to invite him to the stage.
Hello, can you hear me all right?
Hey, Ryan.
Hi, let me share my screen. Is it working fine?
Yeah, perfect.
All
Take
right,
it away.
I'm good to start. Perfect. Hello, everyone. My name is Ryan Aminloo. I attend Portola High School in Southern California, and I'm excited to be able to present the expansive research I've done with Polygence. Today, I'll be talking about the paper that I've done on cybersecurity policies in international relations, but specifically the case of the US and Iran. First, I want to give my many thanks to my mentor, Colleen, who was there for me every step of the way with invaluable feedback that I will remember for the rest of my educational career. And to Polygence, thank you for the opportunity, who I would not be able to do this without. So before I get into explaining my research, take a moment to realize the world around us. Everyone has a cell phone or a laptop in their hands nowadays. We all know the pain of having to wait for that long iCloud backup. The internet is a dominant feature socially in the world, but there's an obscure world behind it with major political implications. It affects all of us. Let's start with some introductions about my project. My research revolves around a new medium or battleground called the cyber domain. It's the virtual computer world where state and non-state actors can interact in ways of cooperation or even for nefarious purposes. The cyber domain is becoming increasingly important in foreign policy for every country around the globe. It defies normal political institutions because now one country that may not have been as strong without the cyber domain can use it to catch up, per se, to its adversaries. This new battleground is thanks to technological innovations in warfare. On one side of the relationship I studied, you have the US. The United States foreign policy, at least within the scope of my research, has to do with having a foothold in the Middle East at all times to counter the likes of its adversaries in that region, especially Iran. The US still adheres to this notion of peace through strength, which was a phrase coined by Ronald Reagan in the Cold War era. If the US can maintain their strength in the cyber domain through superior capabilities, just like how they do in the real world, then they might be in pole position to carry out their foreign policy. The US has only recently started to pay more attention to cyber, but they're increasingly dumping more resources and attention to this space. On the other side of this peculiar relationship, we have Iran. Iran's foreign policy revolves around this idea of being recognized as a major power in the region as well as in the world order on the global stage. Iran was one of the first countries to jump on the expansion of cyber capabilities to catch up to its adversaries. Just like the US, they have a big focus on increasing their capabilities to catch up. Now that the foreign policies of each state have been laid out, to really understand how these two foreign policies interact and collide in a real world scenario, there's a perfect case example. We can see it through Stuxnet. Stuxnet was a computer worm used by a joint program between the US and Israel to delay Iran's nuclear program by using that worm to damage and destroy computers. To put it simply, when we look back in retrospect to evaluate the pros and cons of the attack, it was successful in causing embarrassment to the Iranian regime because Stuxnet attacked a nuclear facility called the Natanz facility that was built deep underground. It's supposed to be untouchable, and the attack was responsible for multiple firings of top scientists who weren't able to explain what was going on at the time. Also, there was some delay to the nuclear program itself, which was the initial goal after all of the attack. On the flip side, it inspired an Iranian comeback. In face of the destroyed computers, Iran actually increased the number of operating centrifuges and uranium enrichment, which basically just means their ability to make weapons-grade nuclear equipment, which means that the attack actually incentivized Iran to work harder. Also, reports have revealed that Iran is capable of reverse engineering and copycatting these attacks that were sent to them and sending it back on state or non-state actors. When the worm Stuxnet attacked Iran from this joint program between the US and Israel, Iran actually reverse engineered the same worm and sent it back on US and Israeli targets. As you can see, this one attack is a perfect illustration of the US and Iran cyber relationship. You have the US, who are supposed to be the big actor that puts pressure on Iran, and then Iran, who are inspired to catch up and retaliate with their own forms of pressure using their advanced capabilities. Wrapping up, there are some considerations for the future of this highly volatile conflict in the cyber domain. Tensions are escalating as we speak in this secretive space, and we could be heading to a point of no return. The escalation of tensions raises this question of whether this cyber conflict could grow into cyber war or even physical conflict in the real world. It's happened before. Israel has launched an airstrike, a physical form of attack, onto headquarters of a prolific hacking group. I want to leave everyone with one thought. The IPI Global Observatory notes if the US believed that Iran was eminently about to target critical infrastructure in a cyber attack, this could provide legitimate justification under international law for a preemptive physical strike against Iranian targets. The idea that cyber war even leads to physical conflict isn't as far-fetched as you may think. It's not out of a sci-fi movie. It's the reality of foreign policy today. Thank you, and I'm now open to questions.
Thank you, Ryan. That was very informative. I thought it was very thought-provoking too. So yeah, audience, if you have any questions, please feel free to text or just request share screen, and then I'll pull you in as well. And while we wait, I just was curious, what's your thoughts on the current events, especially after you've done your research? What are some of your new thoughts, just regarding cybersecurity, as well as just the foreign policies for the next decade?
Absolutely. So I think as for the cyber domain and cyber policies, this is the new wave. This is the new battleground of warfare and even conflict between countries. We're no longer in this phase where everything can be seen in the natural world, where you have one country launching a missile, launching a bomb on another country. Things do happen even on computers. And I think that the cyber domain, these cyber capabilities will accompany these physical attacks in the future. Like I said, when I was talking about future considerations for warfare, these two ideas of the cyber world as well as the physical world, I think those two ideas, those two battlegrounds will go hand in hand in the next decade.
And we also got a question about how should countries collaborate with those new cyber domains and just more capabilities?
Absolutely. So I think the burden falls on international organizations like the UN, or even just diplomatically, the countries themselves, to lay out some agreements over their cyber capabilities. And it's similarly to how countries do to nuclear facilities. We have the Nuclear Non-Proliferation Treaty, the NPT, things like that limit those nuclear capabilities. I think something needs to be done there for cyber capabilities to make sure that things don't spiral out of control. But as for my research, I don't have anything specific, just because that wasn't the nature of what I researched. But I think to that question, that's what I would say would be best.
Got it. And from Judge Alex, she said, well done, Ryan. Great point about reverse engineering offensive technologies. I was curious if you know of any cases where a government cyber offensive technologies has been repurposed by governments or non-government actors against civilians.
Absolutely. So against civilians, I wouldn't say this would be to this notion of reverse engineering, but as for cyber attacks being affecting civilians themselves directly, I mean, you have the 2016 election itself about Russian propaganda in the cyber domain, Facebook, social media companies, things like that affect the civilian population. And a lot of this research and evidence I collected about these cyber attacks, not many are published because it's a lot of very classified information. So everything that I have is kind of what I presented. So I don't really have many other examples of reverse engineering itself. But as for these cyber attacks being used on civilians, I would say the 2016 election is a prime example.
Great. Thank you so much, Ryan. That was excellent.
Of course.
Thank you. All right. So next up, we have Arnav, a senior from California as well. Hi, Arnav.
Hi, can you hear me?
Yes, I can hear you fine. Did you figure out the video situation yet?
Yeah, for some reason it's not able to let me, I can share my screen, but not my video, even though it should be able. I don't know what's going on, but.
No worries. How about this? We will give you a presentation first, and then we can remind you again at the end in case it works out, the whole camera situation. Does that sound good to you?
Sorry, could you say that again?
Do you think we can give this presentation first, and then we will invite you back to the stage once everybody has gone through their presentation so you can say hello and just show your video. Will that work?
Yeah, sure. Okay.
Perfect. Thank you, Arnav.
I can share my screen now.
Yeah, it's the fourth button.
Yeah. No. Share. All right, can you guys see my screen?
Yes, thank you.
Okay, so I can get started. Hi, everyone. My name is Arnav Kethana. I'm currently a senior at Doherty Valley High School, and the research I did with my Polygence mentor Eli Pug was a comparison of language model performance versus human performance on glue tasks. So the area that I focused in was natural language processing, or NLP, which is a subset of machine learning, which essentially teaches a machine linguistics. And a popular benchmark in natural language processing is the GLUE benchmark, which is a set of natural language tasks with popular applications proposed by Wong et al. In 2019. Figure 1 lists the GLUE tasks in order, and the GLUE task we'll be focusing on is semantic textual similarity. But the key issue we are focusing on is that models that are trained on GLUE tasks often overperform humans. And one example of this is on a set of annotators, machine learning models outperform humans on 6 out of 9 GLUE tasks. And this is problematic because when we're trying to train models, we're trying to get something that sees data or sees linguistics in the eyes of a human. So if they're overperforming humans, that means the training has not been accurate. So to analyze this, we compare and analyze the performance of language models on the GLUE task semantic textual similarity, and we train various models such as BERT and Roberta, which are built by Google and are some of the most popular language models to date. And we will use correlation metrics such as cosine similarity and Spearman correlation. So in the research methods, we trained our language models on the STS dataset, which contains a set of sentence pairs with human annotated data. So for example, in figure 2, a group of men play soccer on a beach, and a group of boys are playing soccer on the beach. And then we had human data, which asked humans to rate how similar the two sentences were. And this data was used for comparison of the models. So we used 5 models in our test. The first and most popular was BERT, which pre-trains bidirectional representation layers. And the key thing about BERT is that it predicts mass tokens, in which it hides some of the sentences and tries to predict it later. And the advantage of this is that we only need one layer to train and fine-tune BERT. Roberta also builds upon BERT by modifying some of its hyperparameters, which are the inputs into BERT, and it actually does perform better in terms of language tasks. Distill BERT is also similar to BERT in the sense that it's trained by BERT, so it's pre-trained on raw text. Whereas BERT, we would be inputting human text or human data. We will be essentially taking the outputs of BERT and taking that as the input into Distill BERT. But the advantage of Distill BERT is that it's faster, and it also focuses on mass language modeling, cosine embedding loss, which is similar to what we're doing here, and distillation loss, which is essentially predicting probability. Albert is self-supervised learning, which also pre-trained on raw text. It focuses on MLM and sentence ordering prediction as well. GPT-2 is the unique model we'll be using in our tests, in the sense that it's a decoder-only transformer. It masked future tokens, so something that is not there at the moment, unlike BERT, which predicts mass tokens. And as you'll see in our results, that creates a key difference between the models. So for our analysis metrics, we'll be using cosine similarity, which is essentially calculating the cosine of how similar two vectors are. And this is key because when you think of our data set, we have 2 sentence pairs for each, 2 sentences in each pair, and we have hundreds and hundreds of pairs in our data set. So by taking the similarity of these 2 sentences, which will be we will be converting into vectors. So think of our first sentence as A and our second sentence as B. We will be able to judge how similar they are. The second analysis metric we'll be using is the Spearman correlation coefficient, which shows a difference of the ranks between of each observation. And this is key because now we can, based on the number of observations, we can calculate the cumulative correlation coefficient score. So we are able to output a bar graph of the Spearman similarity scores and the cosine similarity scores of BERT-based models. Of the models, Distill-BERT performed the highest with a cosine similarity score of almost 0.86 and a Spearman similarity score of around 0.6. This shows overperformance in the sense that it's significantly higher at performing compared to the other models when considering their scope. You might think, oh, it's only off by 0.02, like within a 0.1. But in the scope of the model, when we think of it as a percent accuracy, it overperforms a significant amount. BERT and Albert are also relatively similar in the sense that they're trained in a similar way, except they build upon each other. But we can see a clear difference in Albert in terms of its performance, as Albert drops off to around 0.75 and 0.5 in Spearman similarity. And in our unique case, GPT-2, we can see a significant drop-off in similarity score. And this is due to the fact that it predicts on future tokens, whereas the BERT-based models focused on masked tokens, where they were essentially hiding some of it and predicting it later. Roberta was also a very, very popular or very, very high-performing model compared to the other models with the highest cosine similarity score and the second highest Spearman similarity score. So we can see that Roberta and Distill-BERT are the two models essentially overperforming based on these metrics, and that GPT-2 and Albert are the two weakest models in terms of underperforming. So in terms of our future work, we will try to compare with human performance on all glue tasks and perform comparisons with more correlation metrics, such as the Pearson correlation, which essentially compares the mean scores compared to the actual scores and summates that over the square root. And then we would like to propose a new model, and then we'll alter the features of popular models such as Mini-LM and BERT, which are the two most popular models, to propose a more human-like model. And then we'll also choose whether we will focus on a multi-layer or a single-layer network for fine-tuning. And this will be key because all this data will go into how we can change the architecture of the models, or the most popular and most strong performing models we have right now, and kind of propose a more human-like model, as that is the goal of machine learning and linguistics and natural language processing as a whole. I'd like to thank Eli Pug, my mentor. He spent countless hours helping me and helped me through many bugs in my code, as well as guiding me through the direction of my project. I couldn't have done it without him. And I would also like to thank the Polygence team for allowing me to conduct this research. It's been a great experience, and I suggest everyone to thank their mentors and reach out to their friends to see if they're interested, because I think it's a great opportunity for high schoolers to kind of democratize research. If you want to contact me, my email is posted, as well as my mentor Eli's email, and I am open to questions.
Arnav, thank you so much for the great presentation. I have a question. So you talked about BERT, and BERT is obviously a very complicated model, but you also mentioned in future work that you might want to experiment with changing the architecture and the structure. Do you think that would apply to BERT or just to other models?
It could apply to other models in addition, because I just use BERT as an example because it is at least what we believe is the most popular model to date. And as we see when I described about models, I talked about Roberta, Albert, and Distilbert, which are all built off of BERT as a base model. So by trying to manipulate the architecture of BERT, we would be getting more insight into the other models as well. Because as we see, like some of the variations that were more further developed on BERT, like Roberta and Distilbert, they overperformed on human annotated data.
Thank you, Arnav, and apologies. My network froze for a second, so thank you, Janos, for jumping in. Also, audience, if you have any questions, please feel free to leave it in the chat box. And Arnav, I have a question for you. So I was curious what initially piqued your interest in this project, and were there any roadblocks that you witnessed?
Yeah. So I was interested in natural language processing because I started off learning machine learning, and one of the key projects was sentiment analysis that I did, and that's essentially trying to get the emotion from a data set with text. So I realized that various models had different performance. I was trying to get something the most optimal, which is the goal of this project, because then that would just kind of revolutionize what is currently going on in this like subset of the field. As to have something more human-like, that's the essential goal, and that's the goal of natural language processing in general. So if we get closer and closer to that point, it just improves the field as a whole.
Got it. That makes a lot of sense. And I know that Arnav is not able to share his screen today, so I have linked his Gala page in the chat box. So audience, please feel free to check it out and check out his amazing work. Thank you so much again, Arnav. All right, so next up, we will have Sonia, a junior from Irvine, California. And now I'm gonna invite Sonia to the stage.
Hello, everyone.
Hi, Sonia.
I will share my screen.
Sounds
Let's
good.
see. Here. Sorry, I'm having like a little bit of trouble. I think it's okay.
Yeah, take your time.
There we go. Is everything working?
Yeah, sounds good.
Yes. Okay, perfect. Oh, sorry. Little bit of a mishap here. Nothing that we can't fix. Okay, perfect. Is everything good? Yes? Okay, I'll take that as a yes. So, hello everyone, my name is Sonia Fereidooni, and today I'll be presenting on my project about the evaluation of metronidazole resistance within the Bacteroides genus. So, just to give a quick introduction on myself, my name is Sonia Fereidooni. I am from Irvine, California, and I'm actually a senior, and my hobbies include anything that involves learning something new. That just piques my interest. So before I begin, I would like to give a tremendous thank you to my mentor, Surya Tripathi, who has been an incredible person and inspiration to me these past, my research project has actually spanned over a year. So we've been working on this for over a year now. So let's just dive right in. So what do you think of when you picture bacteria? Tiny, infectious, bug-like organisms that are everywhere, right? Well, what you're thinking is 100% correct. And the fact is, a lot of bacteria can be bad for you by causing infections. And that is when you will have to treat them with antibiotic medication, as you can see here. So today we're going to be talking about a very specific genus of bacteria called Bacteroides that exists peacefully in your intestines. However, when Bacteroides is spread to other parts of the body, like the central nervous system, tissues, abdomen, pelvis, skin, and even the head, they can act as severe pathogens. And that is when we will need to start using antibiotics. And this specific type of antibiotic used to fight Bacteroides infections is called metronidazole. So currently, metronidazole is the main antibiotic used to fight Bacteroides infections, and almost all of its alternatives are part of the same antibiotic family, nitramidazole, which can serve as a tremendous problem, and we'll get into more of why that is now. So when a certain type of bacteria, in this case Bacteroides, is exposed excessively to antibiotics, it can eventually gain resistance to the said antibiotic. When antibiotics are used against their target bacteria, they're supposed to kill the bacteria, right? Well, things start to get a little bit more complicated when over time, special genetic mutations occur in the bacteria that provide resistance genes to the antibiotic. So in Bacteroides, these resistance genes are called Nim genes, and there are 11 different types of these Nim genes, 9 of which are we being studying in this paper. So, if a bacteria has even at least one of these Nim genes, it will be able to survive metronidazole and continue to wreak havoc upon your immune system and body. So why is this important? Metronidazole is a widely used antibiotic, and Bacteroides infections are the most common cause of anaerobic infections in the world, and without proper treatment, they have been proven to have over a 19% mortality rate. So the more resistant Bacteroides species emerge, the more people's lives are at risk, and that is what inspired me to take on this project. The fact that without proper research now, this problem could spiral into something much, much larger in the future. So I think this graphic sums it up pretty well, as it projects that by the year 2050, antimicrobial resistant infections will be the leading cause of death, beating even cancer. So this could serve as a tremendous problem to ourselves, as well as our future generations and our children. So it's essential that we put in the proper research now so that we can actually benefit from it later. So just to recap, we are looking at the bacteria genus Bacteroides and its designated antibiotic metronidazole that is used to fight Bacteroides infections in humans, and the presence of metronidazole resistant genes called Nim genes in Bacteroides. So let's dive right into my research. So my research project has been studying the growing resistance of metronidazole within the Bacteroides genus, and the process for me has been threefold. First, to complete blast searches, which I will explain about what they are in the upcoming slides. Second, to develop a phylogenetic tree using Mega software. And the third was to develop a heat map that visually represents this information. So in terms of a blast search, what is that? The term might be foreign to a lot of you. Well, essentially, the process is where you go on the NCBI database, you collect a ton of genetic files, DNA sequencing files, and you compare the DNA of specific organisms to another piece of DNA. So in my case, I took the 62 different species within the Bacteroides genus, and I compared each of their DNA sequences to the 9 different genetic sequences of the Nim genes to compare and see which of the species contained the Nim genes and which of the Nim genes were present within each of them. So I used a 30% or higher identity setting and a 50% or higher query setting. And as you can see over here, this is just a little bit of the research that I conducted on my spreadsheet. So as you can see, here are the 62 different species, and these are the Nim genes. And you can see a 0 for absence of the genetic sequence, or 1 for the presence of the genetic sequence within the species. So this information will be later used within my phylogenetic tree. So as you can see, let's get into the second part, which is the phylogenetic tree research. So I developed a phylogenetic tree, as you can see here, that essentially graphs the evolutionary relativity of the 62 different species within the Bacteroides genus. So this essentially compares which of the species are more closely related along the evolutionary timeline. And the importance of this was to see whether the presence of resistance was more common among specific evolutionary groups or whether it was spread out around the entire genus as a whole. So for this, we analyzed the 16S RNA sequences, which are essential for developing resistance proteins, and I underwent a very in-depth process with DNA sequencing, DNA alignment, and phylogeny within the Mega software to develop this tree. And as I said, the BLAST research would be used to create a marked version of the phylogenetic tree to see which of the species had resistance. So as you can see, 32 of the 62 species have been marked as having resistance. And the essential takeaway from this is that it is randomly spread. Resistance is randomly spread around this phylogenetic tree, meaning that we cannot essentially pinpoint what the next emergence of resistance will be among this genus. We cannot tell because it is spread all around the evolutionary timeline. The third process was the development of a heat map in which I essentially visually graphed which of the species contained which of the 9 Nim genes. This really helps visualize the information. And an essential takeaway from this was that 32 of the 62 species, which is over 51.62% of Bacteroides, exhibited significant metronidazole resistance. So as you can see, here is the heat map. And from this, you can see that of the species that had at least one NIM gene, they had all of them. So as you can see, 13 of the 32 species with NIM genes present had all 9 present, which is a tremendous threat. So in conclusion, we can see that over 1/2 of Bacteroides species are resistant to metronidazole, which is a tremendous threat. And we cannot essentially pinpoint what the next emergence of resistance will be among this genus, meaning that we have to take action now, either by conducting experiments with phage therapy or limiting antibiotic use in order to quell this problem when we still have it in our hands, rather than letting it spiral into something uncontrollable in the future. So thank you so much for coming to my presentation. I greatly appreciate all of you, especially the Polygence staff, for putting all this together. It has been an amazing experience. So thank you so much.
Thank you so much, Sonia. That was amazing. I've learned so much myself. And audience, please feel free to drop your questions. And while we wait, I was curious why you decided to do this research in the beginning. And were you surprised by your findings?
Yes, of course. So I actually came across this topic while I went vegan a few years ago. And in this process, I began studying the human microbiome and how powerful it was in terms of determining someone's composition and just how they behave. And I thought that was really interesting, the fact that bacteria can determine how you behave and compose yourself as a person. So that eventually got me into studying intestinal bacteria. And yeah, so that's essentially how I got led into genetics and resistance. It kind of just went in a pathway like that. And sorry, what was the second question again?
Were you surprised by your findings?
Oh, yes, of course. I was not at all expecting over half of the genus to have resistance. And I know that this topic is actually something that's not receiving that much publicity, and there is not nearly enough research on it. So I'm glad to be one of the few people who are actually researching this genus specifically, especially because it's so common in infections. So I think it was really important research, and I'm really glad that I did it. And I was tremendously surprised. So I hope to further this in the future by studying specific strains of the bacteria as well.
Got it. Yeah, I was gonna ask you, if you have like extra 3 months, what would you focus on? I know you mentioned about the NIM genes and you said different strands. Do you mind elaborate a bit on that?
Oh, yes, of course. So Bacteroides is essentially a genus, right? So there are the 62 species, one of which is Bacteroides fragilis, which is actually a really, really prominent bacteria species within the human body, and it has been known to be the most infectious within the entire genus. So Bacteroides fragilis will be the most commonly one that you might find if you search it up on Google. And specifically, that's the Bacteroides species that I'd like to research the most if I had more time. So I would research each of its strains, as there are like hundreds of strains within it, that you could see which ones specifically have resistance. That I think that would really help the scientific community and in this fight to end resistance.
For sure. Thank you. And thank you, Sharon, for asking questions. And we also have a question from Alex. Alex said, I'm reading his, she said, stellar project. Those methods are very valuable skills. Do populations of bacteroids independently develop resistance after selective pressure from the drug? Meaning like the pressure that kills the bacteria without the NIM mutation. So only the NIM mutant survives. Or can bacteroids share and be transformed by NIM mutations?
Yes, so sorry, is it in the chat so I can reread it?
It is. I know it's quite a long question. It's in the Q&A session.
Actually, I'm not sure why. I'm having a bit of trouble accessing the chat. Is there any way you could paste
No
it?
worries. Yeah, quickly. So there are events and sessions. Do you see those 2 tabs?
No, it's actually not present on mine. It's very odd.
You don't see a Q&A button?
Oh wait, it's sorry, my mouse just wasn't working. Okay, let's see. So, is it if you could take this study to a larger sample?
It's actually a question from Alex. Yeah. So you see chats, polls, people, and Q&A. Yes, Alex actually just posted in the chat as well.
Oh, that's so odd. I see the one that Alex posted for Nathan. I just don't see mine.
Yeah, no worries. Alex, do you mind request share video and audio so I can bring you into stage?
So sorry about this.
No worries. Hi, Alex. You're on mute.
Can you hear me now?
Yes.
Hi, sorry about the confusion there. It only lets you type in a certain number of characters under the question. But my question for you was how Bacteroides develops resistance to metronidazole. Is it only in response to selective pressure, or can they take up mutations that might be free-floating, that might have arisen in another bacteria?
Oh, yes. There's actually, it can arise from other bacteria due to horizontal gene transfer and processes like that. So it's not entirely due to pressures, although that is a huge part of the process for genetic mutations. From my research, I was able to determine that the main cause is the pressures due to just the overuse of metronidazole. They use it a lot in surgeries and things like that. So it has been, it's essentially been bolstering the antibiotic resistance. But yes, to answer your question, it can be derived from both methods. And thank you so much for your question and for unmuting.
Yeah, and then one quick follow-up, if we have time, would be how does, if that's the case, how does that like affect your interpretation of what you are seeing in terms of like what species of Bacteroides have the NIM mutations and the fact that many of them have all of the mutations that you would expect?
Yes, so I think that definitely does provide a lot more complexity to it, because then a lot of furthering research would have to be done in determining like relative proximity to other species of bacteria that might have resistance. And I think that's actually an amazing point, and I would love to further that research in that field to see whether the relative proximity would have to do with gain resistance. And I think that it would actually cause a lot more. It would actually be a huge bolstering, as I said before, to the resistance. And in the tree, you could probably see clades where the wait, actually, I can't share it again. But yeah, I think you will see them popping up closer together if they are in relative proximity to each other. Sorry, I know the wording is a bit weird.
No, that makes sense. Great answer.
Thank you.
It's really interesting. Good talk.
Thank you so much.
Thank you, Alex, and thank you, Sonia. And now, without further ado, we'll have Mahati presenting.
Sorry, are you guys able to hear me?
Hi, Mahati. We're hearing a lot of echoing. Do you have like multiple tabs open for the symposium?
Can you hear me now? Okay. For some reason, I can't hear you. Could you say something?
Can you hear me?
Yeah. Okay. Perfect. So I'll just share. Okay. Hello, I'm Mahati Manda, and today I will be presenting how to predict the efficiency of CO2 capture of metal organic frameworks with machine learning. Before I start, I'd like to thank Christine, my mentor, and Polygence for this opportunity.
Mahati, do you mind sharing the screen again?
Oh, that's weird. I thought, okay.
Thank you.
Sorry about that. Okay, well, I'd like to thank Christine, here she is, and Polygence for this opportunity. A couple of weeks ago, New York was completely flooded due to a tropical storm. In fact, the amount and danger of natural disasters has been getting worse and worse every year. Fire tornadoes appeared in Australia, smog in China is causing childhood asthma, and the existence of polar bears and many other animals is being threatened due to the melting ice caps. All of these problems are resulting from climate change, a disastrous phenomena that is occurring because of the increase in carbon dioxide emissions and other greenhouse gas emissions from our cars and factories. In order to decrease carbon dioxide emissions, chemists have synthesized metal organic frameworks, or MOFs for short. MOFs are crystalline porous materials made from linkers and metals, and they can be thought of as sponges that soak up carbon dioxide instead of water. MOFs capture and store carbon dioxide, which is a gas that binds to the sites inside of the MOFs' pores. These sites are called adsorbophores. There's a problem though. Synthesizing MOFs is expensive and time-inducing. Now, chemists make large databases of hypothetical MOFs, yet it's still a bit difficult to know which ones are the most efficient. That's where machine learning comes in. In my project, I used machine learning to go through the large data sets of hypothetical MOFs and find which ones have high carbon dioxide uptakes and what properties tended to lead to high carbon dioxide uptakes. The machine learning process involves these 5 steps. The first step is to understand the data using histograms, scatter plots, and correlation plots, and identify the feature variables. Then the data needs to be prepared. The null values and anomalies need to be removed to get better results. Certain features such as topology were categorical and required to be encoded using the label encoding technique. Once the data was cleaned and prepared, the data was split into train and test sets randomly. 70% of the data was used to train different models and 30% was used for model validation. The mean squared error was the metric used to measure the accuracy of the model. The models which I used included linear regression, which fits a hyperplane to the variables. Since there were 15 variables after cleaning the dataset, it's very difficult to visualize how the lines would look as they transcend multiple dimensions. So here's a picture that is an example of how 2 different dependent variables and 1 independent variable would look if linear regression was predicting the data. Lasso regression is a different machine learning model to predict the carbon dioxide uptake. Like linear regression, it too tries to fit lines to the data, yet lasso regression applies biases so that overfitting can be prevented. The random forest was another model in which different features are rated with a Gini index in terms of importance and correlation with the carbon dioxide uptake. Some of the most correlated features included void fraction, number of organic linkers, void volume, number of metal linkers, surface area, and weight. The final machine learning model I used was dense neural networks, which included an input layer of the feature variables and an output layer of the carbon dioxide uptake, and inputted different weights and biases at each hidden layer to accurately predict the resultant CO2 uptake. For this model, I used 14 features in the input layer, 28 nodes in the hidden layer, and 1 node in the output layer. In the end, I used 50 epochs and a batch size of 50. In the hidden layer, I used the ReLU activation function. After utilizing and comparing the models, I found that the dense neural networks were the most efficient as they provided only a 3% mean squared error in predicting carbon dioxide uptake. The random forest also performed well as it provided only 7% mean squared error. Linear regression and lasso regression did not achieve such low errors because the features were not strongly linearly correlated with the MOF's CO2 uptake. Principal component analysis, which reduced the number of features from 42 to 7, did not increase or decrease the error, which suggests that reducing the dimensionality did not have much observed effect on the model's efficiency. For the future, I would test my algorithms on Cambridge's Core MOF database as it provides real MOFs. The database that I used for this research consisted of hypothetical MOFs, and so using the core MOF database might account for some of the error that could occur in the reality of synthesizing MOFs. Since the core MOF database includes CIF files as well, which contain some more specific information about the topological structures of MOFs, I would train my models with these as well. In addition to this, I would increase the dependent variables to include CO2N2 selectivity and working capacity so that a more holistic view of the MOF's overall efficiency can be provided. In the end, my goal of applying machine learning to carbon dioxide absorbing MOF data was achieved as I was able to reduce error to about 3% in predicting the carbon dioxide uptake of hypothetical MOFs. Thank you. Are there any questions?
Thank you so much, Mahati. That was a great presentation. I was just curious, what was the hardest part of your research process?
It was probably like we ran into a lot of problems in finding good data. So when I was looking into different data sets, some of the data was like really weird. Like for example, for some of the volumes, it was negative. So we had to take out those anomalies, but in other data sets, the data was just not properly correlated. For example, when surface area increases, I would expect carbon dioxide uptake to also increase so that there's a positive relationship. But for one of the data sets that I tried using, it was a negative relationship, so I had to take that out. So yeah.
Got it. And we have another question from Q&A. Yeah, so Alex said, really important topic, Mahati, and wonderful talk. What is the effect of temperature on MOF efficiency? What does that mean for the potential use of MOFs across different climates of the world?
Okay, that's a great question. So there's a certain temperature that keeps the MOFs stable. In this data set, these were the different descriptors that I used. So temperature wasn't exactly one of them, but I think that would be a great further research opportunity. So just to clarify, there were I did find like heat absorption at different pressures and temperatures, but this was also to keep the MOF at a certain stability while they were testing the heat absorption.
Got it. Thank you so much, Mahati.
Yeah, thank you.
Yeah, so again, I want to thank all of our presenters today. And I want to know, has Arnav figured out the camera situation yet? Because I would love to have you say hello to our general audience. You can just give me a quick yes or no in the chat box. Perfect. I'll invite you back on stage now.
I'm not sure.
Okay.
I can try. It says cameras allowed, but it still doesn't let me.
I see. Okay, I see.
I guess you guys, if you want, you can look at my PolyNet profile.
Yes, please find it in the chat. You can check out Arnav's wonderful scholar page. And thank you again. All right, so thank you all so much for all of your hard work in our project. And a huge thank you to all audience members for coming to support student presentations. We at Polygence are incredibly proud of all of your achievements. And we're so glad that we got to cheer you on and celebrate you on stage today. And as the last event for the day, please join us at the stage for the closing ceremony. Thank you so much again for everyone for coming. Thank you again.